Okay, good morning, pirates. Today we are going to just review. I wanted to make a short video reviewing your work from yesterday. I took a look at your responses and they were pretty good. I just want to talk about a couple of misconceptions. And so, looking at C, the first thing I noticed is that we are being asked for end behavior. And so when we have an exponential function and we're asked about end behavior, we need to determine whether or not it's growth or decay and use our knowledge of how functions translate in order to answer this problem. Okay, so first thing I look at is that this 3 is bigger than 1. And so that means that our function starts out as growth. Okay, second to that, we're going to look to see if we have any reflections. Reflections happen when we have a negative x or a negative value in front of the b value, which we have both, which means that this function is going to go from growth to decay to growth. And it always starts out when we look at that 3 as this shape, right? Growth always starts based on the b would be that shape, whether it's 10, e, or 20, it's all going to have that shape, just the scale will be different. When we do the reflections, it doesn't matter which order you decide to reflect this in. I typically will flip over the y-axis, only then to flip over the x-axis. But you can do it in any order you want. But when you start with, when you have the two reflections, growth to growth, this is the beginning result, the beginning, and this is the end result. Okay, so in the only other thing we have to look at is our minus 3, which turns out to be our horizontal asymptote. Again, if that number is not there, then it's 0. And so therefore, we would say the limit as x approaches positive infinity is going to be negative 3. Okay, so question D. Same process. Let's start with the inside. The inside is 1/3, which is less than 1, making this problem decay, but we have 2 negatives, which result in 2 reflections. So again, we're going to see that we start with decay, go to growth, and end with decay. And just like the growth model, this starts out the same way every time. If it's less than 1, that's the initial shape of your graph. We can then flip over. You can do x or y axis. I tend to always do the y axis first, resulting then in an x axis, which is going to flip it down. If you have 2 reflections, you'll see the same pattern that you saw with growth, that it'll start this shape and end this shape. Okay, so the final piece to this problem, again, we want to take a look at the +1. That is going to be our horizontal asymptote. So we got y equals 1. So now we have a general idea of what the graph is looking at, and now we want to talk about what is going on when the function approaches positive infinity. Well, positive infinity is this way. And so this is going towards negative infinity, therefore DNE. Okay, so problem E and F were a little bit different than the other problems you were asked for. We're not looking for end behavior now, we're looking for a limit at a point. And so when you're asked for a limit at a point, you need to go back to just that flow chart on the front of the last lesson, evaluating it algebraically. So what I want you to do is I want you to first try direct substitution. And so when we try direct substitution, we get e to the -1 minus 1. And so because this is not calculator active, this is an acceptable answer on the AP exam. This is an acceptable answer. I'm going to give you 2 more just in case you're feeling fancy today. You could write 1 over e minus 1, or you could write 1 minus e over e, depending on if you're really feeling fancy. All of these answers would be accepted on the AP exam. And by the way, if I'm analyzing this function just for the fun of it, this is a growth function with no reflections. So we generally know that the shape of this graph is going to be like this. And we're going to have a horizontal asymptote at y equals -1. Okay, the final problem of your assignment was F. I'm going to start with the analysis. Not that you have to do it because, again, we have a limit at a point. It's always good to kind of know the shape. We had a decay function that then changed because of that -x to a growth function. So, again, you start with a decay, and then because of the flip, we flip to growth. And so if you were asked about the end behavior, these things would be important, but we were not. So what we want to do is, again, try direct substitution. So I've got 1/2 to the -3 minus 1 plus 5. An acceptable answer, again, on the AP exam, 1/2 squared plus 5 is workable, and so is 21/4. You could put any of those three, and that would be accepted. All right, so moving on from Monday, we're going to talk about the other types of transcendental functions, which are trig functions. If you have any questions, please make sure you reach out. Have a great day.